If you are going to the Data Council Austin event in January on the 27th and 28th, you're definitely going to want to meet Costas and me in person at 𝗪𝗪𝘁 on the night of the 26th. We will buy you a drink and talk all things data. We will be on site for the conference, and we're super excited to meet you. Costas, tell me what you are most excited about asking our listeners if they actually show up to meet us in person.
If you come and visit us, like, you will have the opportunity to play this new game that we don't have a name yet, where I say this is interesting and we all take a shot of tequila or something like
that. Maybe you can play that game. I don't want to do that many shots of tequila, but we would love to meet you in person. It's going to be a great conference, and we're excited to meet some of our listeners. So come by January 26th. You can reach out to us on datastackshow.com, fill out the contact form, let us know you're coming, and we'll buy you a drink. See you there. Welcome back to the DataStack Show. Today we're going to talk with Vinoth, and he works on Hudi at the Apache Foundation. And so we'll talk all about Hudi is, if you don't know what that is. But he has an unbelievable resume. I mean, just so impressive. And I'll give a little bit away here and probably steal the show with my question, Costas, but we've talked with some people who have worked on technology inside of large companies like Netflix that has later been open sourced and sort of made available generally. But we haven't, at least to my knowledge, talked with someone who was there at the beginning and really started it from the very beginning. And I just want to get that story. Like, what were the challenges that they were facing at Uber? Where did the idea come from? And then, like, how did it actually come to life inside the company? So I think that sort of origin story is going to be really cool to hear about Hudi.
Yeah, absolutely. And I think it's probably like the first open source project that it's actually an Apache project that we have here as a guest. Right. I think so. So that's going to be interesting because, okay, this is also important. It's one thing to have like a project, to open source something on GitHub. And it's another thing to have something that's governed by the Apache Foundation. So it's especially from the governance side, like, it's a very different situation. So I think that's going to be very interesting to chat with him. And okay, Vinoth is a person who has been like in the right place at the right time in many occasions when something interesting around data was created. He was in LinkedIn, Uber, Confluent later on.
Yeah.
So, and he's one of the, I think it's one of the best people out there to talk about what the data lake is, because that's what Hudi is. And it's going to be very interesting to see how he started playing with the idea of like building something like a data lake inside Uber, and why these got open like as open source, and why now data lakes are so important and so hyped. So I'm very excited. I think we are going to have a very interesting conversation with him.
All right, well, let's dig in.
Yeah, let's do it.
Vinoth, welcome to the show. We're so excited to chat with you.
Yeah, great to be here. Thanks for having me.
Well, in the world of data, I think it's safe to say that your resume is probably one of the most impressive that I've ever seen. So do you want to just give us a quick background on your career path and what led you to what you're doing today with Hudi?
Yeah. And first of all, I don't know if I am deserving of all those kind words, but I tend to think of myself more of a one-trick pony who keeps doing databases for over a decade, because that's the only thing I know. So for me, I started first job out of college, UD Austin, was Oracle, work on the Oracle server, data replication, what passed for stream processing back in the day, SQL streams, Oracle, Golden Gate, data integration, CDC. That's where I started. Then moved on to LinkedIn, where I led the 𝗪𝗪ci𝗵𝘁𝗵 store. I think most people have forgotten that project by now, but it was like, like LinkedIn's Cassandra. It's actually a pretty popular project, and actually led that, and we scaled it through all the hyper growth stages for LinkedIn, from like tens of millions of users to hundreds of millions of users. That's what lasted us through that. Then I moved on to Uber, where I was the third engineer on the data team, where we had a 𝗪𝗁 cluster and some Python scripts. And that's kind of like, this is Uber, 200 engineers or 100 plus engineers, and back in 2014. So I spent almost 5 years there working on data. I had, since I joined yearly, and that's kind of what I was looking for when I left LinkedIn, is like, a blank sheet of paper in which I can actually try, work hard, try to build something new, make mistakes, learn, like all that journey I wanted for myself. So Uber gave me that, and we ended up creating Hudi there, which kind of like has become, it's great to actually see how the space has evolved over the last 4 years. I also did a lot of other infrastructure things at Uber, including Uber's one of the first companies to adopt HTTP 3, if you will, as it was getting standardized. I still don't know whether it's fully standardized. So we ran quick over and then replaced TCP with UDP-based condition control. Oh, wow. And so I like to dabble with a lot of infrastructure stuff. I was used to work with the database teams at Uber. So then I left Uber, went to Confluent, where I met some of my old colleagues from LinkedIn, worked on yet another database, 𝗖𝗁cie and parts of Kafka storage, Connect, and so generally been around this stream processing, database, data pipeline, this kind of space for a while. And yeah, I'm like, I have some time now to actually dedicate full time to Hudi. Hudi was something that I kept growing the community in the open source in the ASF for almost 4 years now. And then I finally have some time to dedicate to Hudi, and then I'm enjoying that this year.
Very cool. Well, first of all, I don't know if after hearing that, my conclusion would be 𝗪𝗁𝗁𝗵, but okay, so I have so many questions, but one thing I'm really excited about is we've talked a lot on the show about trickle down of technology from organizations like Uber, Netflix, et cetera, that are sort of solving problems at a scale that just haven't been solved before. And some really cool technology emerges from that. But we haven't been able to talk with someone who is part of the sort of development of that from the beginning. So could you we just love the story of Hudi. What problem were you trying to solve? And I think in the age that we live in, it's sometimes hard to think back to, 2014 and what the infrastructure was like back then. But would love to know like the tool set you were working with, the problems you were having, and then just tell us about the birth of Hudi inside of Uber.
Yeah, I think it's a good, fascinating story actually. So 2014, as you can imagine, Uber was like, we're hiring a lot, we're growing a lot. It's like launching new cities every week, if not every day. And so we're really in that phase. And if you look at what we had a typical on-prem data warehouse. And while 𝗪𝗁𝗁𝗵 has a really great 𝗪𝗶𝘁 query engine, but it's not really, we couldn't really fit all of our data volumes into it. If you look at all the IoT data or the sensor data or like any large volume event stream data or any of these things, they don't fit inside that. So we built out Hadoop data lake. Most people did. I came from LinkedIn before that, so very well, like till that I knew the runbook to what to do. You do Kafka, you do like event streams, you do like CDC, change capture, get a lake up and running, and you do.
So that was like familiar territory. Like
that was familiar. The things that we really replaced, the certain things I wanted to fix over, kind of like what we didn't do at LinkedIn, which was we wanted to ensure all data is columnar, never have a mix of like JSON or don't do. So we essentially forced and built the entire company to schematize the data and built a lot of tooling around it end to end. You would get a PagerDuty alert if like data is broken, all of that. So we did a lot of things to actually ensure that the lake can be operationalized. And within a year, we had a lake where you can do, the data was flowing in, where we can do Presto for interactive querying, some Spark, ETLs, and Hive, which was still the mainstay for ETL at this point because Spark was 1.3, like this is coming up, right? Yeah. So the main problem we hit was, as you can imagine, Uber is a pretty real-time business, right? So what we weren't able to do was we had our trip stores upstream, a lot of different databases. We wanted to take the transactional data, which is kind of changing, and reflect that onto the lake. With something like 𝗪𝗁, you already have transactions, updates, merges, like it can do these things, it can indexes. And while the data lake could scale horizontally on compute and storage, it cannot do these things. So that led to the creation of Hudi, where we said, hey, look, we are between a rock and a hard place. We can't fit all this data there, but we don't have these functionalities here. So we chose to basically bring these database functionalities or data warehousey transactional functionalities to the lake. And that's kind of how Hudi was really born. And the key differentiator, I would say, from some of maybe the other projects in the space would be right away, we had to support like 3 engines, like Presto, like 3 I mentioned, had to work out of the box, right? And the other thing is, like with every company, we had our raw data, then we build ETLs on the lake after that. So it's not sufficient that we just replicate the trip data very quickly by building updates and everything. We also had to build the downstream tables quickly. So we essentially borrowed from stream processing a lot, having like worked on stream processing systems before. We built CDC capabilities or streaming incremental streams into Hudi, even in the very first version. And so that we can actually, the effect was upstream data store every few minutes, it's up to date with a downstream table on the lake. And then you can consume incrementally from that lake and build more tables downstream. So we kind of moved all of the core data flows at Uber into this model. And that gave us 10x, or in some cases, like for our given tables, even 100x kind of like improvements over the way that we used to process data before. So fundamentally, Hudi was created around the concept of, okay, yes, we added transactions, updates, deletes, but the bigger picture was this enabled you to process everything incrementally, as opposed to doing big batch processing. That's kind of how Hudi was born.
And wow, I feel like we could talk for 5 hours because I have so many questions, but quick question, less about the technology. What was the size of the team, and how long did it take you to go from sort of the idea or the definition of the problem, or maybe like early spec, to sort of having an early version of Hudi in production?
Yeah. Okay, it's kind of like a funny thing because I started writing like a first kind of draft, or at least for the writer transactional side, I think in my second month at Uber. But we didn't get to build it until for a year because we put the business first. We're just trying to build an operation. There's so many other things to build. But finally, we decided to kind of fund the project with 3 people in, I think, late 2015. And then by mid 2016, we actually had like our mid or late, like, Q3-ish, late Q3-ish, we had all of our core ingest tables at least like running on the project. And I thought we were able to only do that because we use existing horizontally scalable storage. We used all the existing batch engines, right? So we didn't write a new server runtime or like build a lot of things. We didn't try to build like a kudu, for example, right? Which was like its own, something that we considered, by the way, back then before building this. Yeah, and then I think we opened this as a project pretty early in 2017. So Hudi was the first sort of like trailblazer for like transactions on a data lake across multiple engines. And we mostly wanted to open source it because we weren't really sure if we were doing the right thing back then. So we wanted to get more feedback. I can tell you now it's like super visionary and all that, but no, like, we were like, okay, we're doing something a little bit awkward. At least it felt a lot awkward to the more of the Hadoop people who grew up in the Hadoop space. To me, it felt very natural because I was working on key value stores and databases and change capture before that. So it all was like, but there's like a lot of the bridges to cross before I think it became a mainstream thing.
Can you give us a definition of what data lake is?
Wow. Okay. So in my mind, at least, so most people, if you ask them, I'll start with that. Like a data lake is files on like S3 or GCS. So that's kind of like the perception that people have. In reality, I think we built what I would call a honest data lake architecture at Uber, which is what it is. So data lake is basically an architectural pattern for organizing data. Like you can even build data lakes on like an RDBMS if you want. The main idea is you replicate your operational schema raw, keep it like simple there. So you do a EL and then you do ETL there. And then you try to keep, but it's been over years overloaded with a lot of different constructs here that it means Hadoop in some people's mind. It means like S3 in some people's mind, or Parquet in some people's mind. So the basic idea, I think, remains that, which is like you do this like raw and derived data. And from the impact that we saw at Uber, what I can say is embracing that architecture has a lot of key benefits. It completely decouples your backend teams or data producers and your data consumers have this raw data layer now, which they can use to actually even figure out what the data problems are, right? Otherwise, a lot of people do transformations in flight. So you can't really you have to go to the source system to reboot stuff. We had a lot of basic issues around just how we do the data architecture. That's how I see a data lake to be, like an architectural pattern.
Yeah, so that's a very interesting definition, actually, and probably the most accurate that I have here, like so far. Because to be honest, like also personally, like I'm still like a little bit confused. Like you can see like many different pieces of technology that they fall under like the umbrella of a data lake without being very clear what the role in the data lake architecture is for them. And obviously marketing doesn't help with that stuff, especially now that we have all this like the lake house. We're trying like to, let's say, take the data lake and make it equivalent to a data warehouse and vice versa. And that's my next question. What's the difference between a data warehouse and a data lake in terms of like as architectural patterns, right?
Got it. So I'll now actually talk about how the system design of data lakes and data warehouses typically have been, right? That is what I think most what I think what you're speaking to. If you look at if you take a minute, right? If you just go back to how we were doing Vertica or Teradata, you essentially bought some software, installed it on like a bunch of servers, right? They had deep coupling between storage and compute. And it's a fully vertically optimized stack, right? So having closed file formats like one query engine, one SQL on top of that data on like a fixed set of servers gave them like they were able to probably squeeze out performance per single core, right? So that is how your on-prem or the traditional data warehouses have been built. And your data lakes typically rely on, even from the Hadoop era, right? They rely on, HDFS or cloud or some horizontally scalable storage. You decouple the storage and then you can fit even back before, right? Even before, even if we go to 2014, you can fit like I mentioned, a Presto or a Spark or a Hive on top of the same data. So the fundamental difference here is the data and the compute are more loosely coupled in a data lake. And they're much, much more strongly coupled on a warehouse in terms of like across the stack optimizations and how it's built. With the modern cloud warehouses, they've changed the game where they've actually decoupled the storage and the compute, but the format and everything else is still like vertical, right? So there's like one format for Snowflake or BigQuery, one SQL, and it just like operates in a different way, which gives you a lot of scalability over traditional warehouses. So that's why you see a lot of people talking about, you don't need data lakes, you just need like cloud warehouses, right? So if all you're trying to do in life is just BI, maybe they're right. At the cost aside, maybe they're right. If you now go to cloud, so while the cloud warehouses have like leapfrogged on-prem warehouses and evolved, if you look at on our data lakes in the cloud, they're very similar to how they were on-prem. Correct. So that's where we are today. And that's where the sort of the lake house comes in. And I think we did in like, pioneer kind of transactions on the lake and all of that, but we didn't call it the lake house back then. Mostly because I still felt even today, the transactional capabilities that we have in a Hudi or like all these similar technologies are like much slower compared to what you would find in a typical warehouse, full-blown warehouse. So we were like a little bit shy about those things, but I think many people weren't. But that's kind of like what we refer to lake house now, right? So we brought some of these core data warehouse functionality back to this data lake model, fit it on top of like a 𝗫𝗁 or a 𝗏𝗁 kind of like open format, and then make it accessible to multiple engines. That's what a lake house is. And it gives you the sum is the important part, some of the capabilities of the cloud data warehouse, while it still retains the advantages over a warehouse, the lake has over a warehouse. For example, it's much, much more cost efficient. It's way cheaper. You can run like, eventually, if you think you're going to need machine learning or data science, it's a more forward-looking way to build where you get your data first into some sort of like lakehouse thing. And then you do your analytics and data science there, and then you can move a portion of your workload into a cloud warehouse, right? So that's kind of like, I feel like we will go back to that model in the next few years, because the cloud data warehousing architecture fundamentally doesn't really suit running large data processing on them. So at least a good chunk of the market, I think, will move towards this model, I think.
Yeah, that's interesting. I remember like I was talking recently with some friends in a company where traditionally they had, let's say, when it comes like to data management and data processing, like they had like two parallel paths. They had the data warehouse that was used for data analytics and BI. And then they also had, let's say, a data lake, and it was based like on Spark and on top of like S3 that was used from the data science team. And what they want to do now is actually they want to move into this, let's say, Delta Lake, but like the lake house architecture, so they can merge these two together. So the two teams inside the company don't use like two completely different, like stacks for their work. So that's very interesting to hear also from you, because it resonates a lot like with what like people are trying to do. You talk about transactions and getting transactions and implementing transactions on top of like the data lake. Why transactions are important? Why we need them?
Yeah, so if you look at how, let's look at it through the lens of like a use case, right? GDPR. I look back at GDPR and I could see that was the one use case that kind of trickled Hudi down to everyone else, because till then, if you look at it, the stuff that I talked about at the end, sure, Uber had the needs for a lot of business, like faster data, and we did it a certain way. And anybody who does that will get the benefits, the efficiency gains that we got. But there are the business drivers for that weren't simply there before something like GDPR. So you need to ingest data, and then you need it like a team now to go scrub the data and say like delete people who left your service or something, right? So this kind of like you now introduce two teams who want to operate on the same kind of like data set or table. And then now that forced updates, deletes, and transactions. And that pretty much is what kind of like made this into like an inevitable sort of transition. If you're doing a lake, you're going to probably want to just move into one of these like newer things now, right? So that's kind of like the main thing, I would say.
Okay, that's very interesting. And like you said at some point that, okay, we take something from the database world and we implement it like on top of the file system, which is the transactions. But again, like the transactions, the way that we implemented them is not like exactly what you see like in a data warehouse, right? So what's the difference?
Yeah.
Like, what is there that we don't need?
Yeah. So here, I think there are significant key differences. Like people tend to talk about the like Delta Lake or Hudi in the same kind of like thing, because we like to compare things, and then it's easier for us to compare things and understand, right? But if you look at the concurrency model, even they're completely different how they're designed. So data warehouses do like multi-table transactions, for example. Like here, we've been saying on the lake, lake house, we've been saying, yeah, we can do it. We can probably add multi-table transactions, but the locking that you do, they can do more pessimistic locking. They probably can, since they have long-running servers, they can probably do a lot more unique constraint foreign key validation. These kinds of things that you would expect in a like full-blown database, they're able to do today, right? So yeah, and if you, the other key difference with the current lakehouse architecture is it's kind of like serverless, right? It's like a serverless, whatever, warehouse, if you will, that comes up part by part as needed on demand, right? Okay, just like the writer comes up, writes, and then goes away. And then like a reader comes and goes away. So there is no long running things that you can do to do coordination. So that's like for some interesting challenges, right? So if you take a look at Delta Lake, they pretty much do optimistic concurrency control, which basically is if two writers don't contend, you're fine, but otherwise one of them fail, right? And if you look at the approach we take in Hudi, we try to serialize everything. We try to resolve conflicts by supporting log structures, differential data structures. We try to take in the writes and then sort of do collision resolution later on. And we try to, because end of the day, data lakes are about high throughput writes. These transactions are in database terms, very large transactions. So you cannot really afford to have one of them fail. Like imagine like a delete job that ran for 8 hours and it fails now, and then you lost like some 8 hours of compute and all this cloud, right? So we took a very different approach. I could see, because we were focused a lot more on streaming CDC data in and like all of those incremental use cases. If you look at Databricks and Delta Lake, probably they have a lot of batch Spark workload that they run. So they probably don't get that much concurrency overlap. So maybe OCC works well for them. So just like with databases, like how we have an Oracle, Postgres, or a MySQL, I think there's so much technical differences with these projects that we will end up with like a bunch of these things, I feel, over time.
Yeah, makes sense. Do you see, like, that's my last question around like transactions. Do you see the transactions from the data lake to get closer and closer to what we have in databases? Or you think that is like, there is a limit out there that it doesn't make sense, or we cannot, let's say, pass?
I mean, we can build the same thing. We are actually in Hudi, at least we are experimenting with adding a meta server. So essentially so if you look at the problem as data plane and sort of metadata plane, the data warehouse has servers for both data and metadata. The lake has no servers for both data and metadata today, right? With the way that things have evolved with like Delta Lake or Iceberg, right? Where you stick metadata into a file, right? I mean, that's not going to be like performant if you compare to what, let's say, Snowflake does, which is like keep metadata in another OLTP, horizontally scalable OLTP database like Foundation DB, for example. So we are trying to tinker with a model where we have servers for metadata and we keep the data plane like kind of serverless, where Spark jobs should be able to access S3 raw direct. Right. So that's one thing we feel like will bring it a bit closer. This I feel is the gap in the lakehouse architecture today. But I like the first aspect you mentioned, right? Like, do we need to do that? So that's the other part. So unless you're running really lot of concurrent workloads, today there isn't like a pressing thing, right? The lakehouse vision is just starting up, but if you have to fulfill that, I would imagine that you need like a full set of capabilities. People should be able to run workloads on a lakehouse, which are like highly concurrent and highly scalable as they would on like a warehouse. So I think there are technical gaps and a lot of things to be built in the next couple of years or more going forward there.
Super interesting. And Outside of transactions, what else do you see as a component from like a more traditional database system that it is required also from a data lake or a lake house?
Yeah. So I don't know if this fits into the lakehouse model, but at least for Hudi, we actually borrowed a lot from OLTP databases as well, like indexes, for example. We have an interesting problem for CDC, right? If you, so okay, you have an upstream like Oracle or Cassandra, some OLTP databases taking writes. If you have to replicate that downstream to like a data lake table, then, I mean, why are the updates faster on the upstream OLTP table? Because they have indexes and like whatnot to like update them, right? But if you have to keep up with an upstream OLTP table, your write on the data lake table has to be like, feel like you're writing to a kind of like an OLTP table. So we invested a lot in more sort of like, so this problem is similar to running a Flink job, reading from like a Kafka CDC and then updating a state store, essentially the stream processing principles. So we borrowed a lot from stream processing and databases and brought it also to the data lake. And that is, I think, at this point, a pretty unique thing that we've been able to achieve. If you look at a lot of Hudi users, they are able to stream like a lot of data raw into the lake very quickly. And that's all possible kind of like because of this. But for the core warehousing problem, I think we already have columnar formats. We close the loops on transactions and get the usability there. That's something that we haven't talked about at all. If you compare Stack, we've talked a lot about technology, but if we talk about usability, how quickly can you build a lakehouse versus how, like starting on a warehouses win all the time, right? Yeah. So these kinds of things are more important for the lakehouse vision, I think, than, but we are trying to add more capabilities on the lake than even a typical warehousing would that you do today.
Yeah, that makes total sense. And what about the query layer?
Yeah, that's an interesting one. So I think today, if the lay of the land is you pick if you are on the lake, you pick like Presto, Trino, equivalent for a lot of the interactive queries, and you write Spark or Flink or high VTLs. I know I'm broadly categorizing, but that's the major things that pop up, right? And the key thing to understand here is there is a lot of things that we don't typically even classify as query engines, like all different NLP frameworks, or like some of them are not even distributed, right? There's like but they still work on these open data formats. So there's more kind of like more fragmented sort of like tool set around the ML, NLP, AI, deep learning, like that space that is also kind of going to kind of only grow. So I don't see a future where there'll be more query engines on the lake. There's going to be like more and more query engines. And I think the smarter strategy here would be to, have a lake kind of a strategy again and build towards that. Keep your data sort of like in an open format that you can buy support from many people and kind of like have it be more future-proofed. That's kind of like what I think inevitably this is going to lead organizations into.
Yeah. I'll ask something like from the completely opposite side of the stack, because we are talking about we talk about like the query. And correct me if I'm wrong, but what I understand is that the data lake at the end, like your work as the creator of like Hudi, for example, is to build, let's say, table formats on top of some file formats that we already have. That usually we are talking about Parquet and 𝗏𝗏 here, right? Is this correct, the way that I'm understanding it?
Yeah, so the thing that this table format term, again, is like, doesn't do justice to sort of at least like what Hudi has to offer, for example, right? There's a lot more than what you need than a table format. So if you look at what a table format is, it's a metadata of your file formats, right? Around what, right? It's a means to an end. What I think we built in open source today is a lot of the services that also operate on the data, because without them being open, it doesn't matter if you pick an open format, right? You don't own the services that operate on them. So you have to basically, you're saying, I have to buy some vendor who will operate these services for me. So this is the gap that I think like something like Hudi fills here. He's speaking for Hudi. We have compaction, clustering. We have the bottom half of the warehouse or a lakehouse or a database, whichever you want to use, kind of like available to you, which you can now use to query multiple different file formats with. And to your point, yes, mostly it's analytical storage, right? But if you look at Hudi, there are some use cases that come up where people really don't want a database, but they want like a point, like a key-based lookup on a top of like S3 data. We support H file as a base format, for example. Like H file is the underlying file format for HBase. So it's like really optimized for, it uses range reads to do like get batch. You can do like batch point key gets from H file. So there are, I think, going to be like more and more use cases like this. I can totally imagine how this can be used for, let's say, hyperparameter tuning or something on a machine learning pipeline, right? So I think there's a lot more that we probably haven't built. And this space is sort of like still nascent, in my opinion.
Yeah.
For all the reasons that I've been citing, it's still a lot more work to do here.
Do you see like any innovation, any space left for innovation, like when it comes to the file formats themselves? Because, okay, we take for granted like 𝗪𝗁 out there or ORC, but like that's pretty much what everyone is using, right? Do you see like anything changing there, or we need something to change there?
Yeah, so that's the thing, right? So oftentimes in open source, that's the other kind of like I've been in open source for 12 years. So, but my own pet gripe is sometimes I think what wins is the most popular is what happens, right? It is a popularity contest in some sense, it becomes that. While on a more managed service, you get swapped out with something that happens new. So I think for a change to happen at like that file format layer, I'm pretty sure that there can be a new, better file format that can be written. Even like Google has a capacitor is the file format on top of underlying BigQuery, right? It is a successor to Dremel, which is what 𝗪𝗁 is based on. So you can read a blog. They don't open source the format this time. There's already one there, right? Yeah. So it's more like if we've done this now, so like it's going to take a while for people to migrate and all of this. But I'm pretty sure with like new processors coming out all the time, and there's not documented things around like CPU efficiency, around like how you access 𝗪𝗁. So there's like plenty of room for improvement, I think. Like original 𝗪𝗁 was designed in an era where mostly on-prem HDFS, right? So you had to care a lot about storage space. But if you now don't care as much, would you do certain things differently? I haven't put a lot of thought into it, but I'm pretty sure there's something that is better that can come out in the future.
That's super interesting. Cool. You mentioned open source, so let's spend some time like on that aspect of the data lake, because let's say we have like three, as we said, like major technologies out there. All three of them have like some open source presence. And I will start my question with asking you why data lakes are open source, like we can see open source there. And when we are talking about data warehouses, I don't know, I think instinctively the first response will be, we don't have an open source data warehouse, right? Why is that?
I honestly feel this all started from like the Hadoop data lake, Hadoop era, basically, where I think Cloudera, if my memory serves me right, they like boldly declared that like everything open source is the way to go, and I think I agree. But it's basically been a trend from there, because like Spark was open, like the major tools that have succeeded have been open, right? And then I think we ended up with like the lakes being open and the warehouses being more closed. I don't know why that is though. I do see that there is advantages in being closed and moving faster, and you can build more vertically optimized solutions. So historically, databases have been that way. If you even take like RDBMS, we won't even talk about something like this in OLTP databases, for example, right? We won't say, why don't we have a common table format and let's have Spanner and or 𝗬𝗓byte and 𝗬𝗁𝘁DB all query that format or something. So I think I don't find that very weird. I won't be the person who would say, yeah, it should just be open, otherwise it's wrong. I don't think that's true. I do think that to that point, what do databases add? They add a lot of runtime over that format. And then at that point, you're not dealing with the format, so it doesn't matter whether it's open or not, right? So what I really care about, again, going back, is whether these services are open, right? Can you cluster a Snowflake table outside of Snowflake? If you don't buy that, maybe there is someone who can use AI and super cluster your tables automatically. They know this is like a genius who has this a clustering algorithm. Can you use it? You can't, right? So I think that is the main thing that I would say that the lakes bring. And it's been that way. And I feel on the flip side, warehouses do have better out of box, easy to get started. And those things, they've made it work at the cost of openness. And on the lake, I would say people still have to build a lake, right? You can use a warehouse, but you have to build a lake. You can either download one or you sign up on something and use it, right? But you have to go hire a data engineer, hire some people, build a data team, and then they will build a data lake for you. So there's pros and cons to both approaches, I would say. I think, I don't know which one's right.
Do you think this is going to change for data lakes? Do you see more effort put towards the user experience, let's say, of these technologies?
Yeah, I think there's certainly, at least we are doing it, and we've been doing it that's kind of how we even got started. If you go to Hudi, you will find a full-fledged streaming ingestion service, right? There is a single Spark submit command that you can run, and then the tables gets clustered and cleaned, and all this indexed, and all this Z ordering or Hilbert curves or stuff that is logged away to even table, Databricks or Snowflake, you can find in open source. And we try to give you a tool set where you can actually run it easily. But here is what I see. I think even as we make it more and more usable, more and more consumable, it's still the operational aspects of it. I do see people on the community, really talented, driven engineers, data engineers who come to the community. They're trying to pick up all these database concepts, trying to understand what data clustering is. Why, do I do linear sorting or Hilbert curves? They're trying to understand all these fundamental database concepts, try to become platform engineers, try to run 1,000 tables and manage that entire thing for their company, right? And many of them come out with flying colors, some of them don't. And in any case, it takes a year or more for people to get through that learning curve and do this. So this is where I wonder where there is a better model here, where companies should be able to get started with as easy as how it is. I mean, okay, don't worry about all of this. Just get started with all of these lake technologies. Then, yeah, maybe you want to do it yourself, right? So then they should be able to fork off. This is what I'm suggesting is pretty much a reverse of what most open source go-to-market people tell you, which is you form a community and then you make it so that you keep it bare minimum and then people can use it, and then you build more advanced stuff on top. But for the lake, I feel with Hudi, we try to make everything easy, but the problem is people still need to take it and run it. It's not non-trivial thing to operate a database as a service, right? Having done that, Walmart as a service, I do LinkedIn and 𝗓𝘁 on the cloud, and I can vouch for that much. I can talk with some authenticity. So we should make it easy for people to get started with a lakehouse, or a lake or whatever. And then at a point, your business will grow where it needs data science. Business will need ML, right? At that point, you can decide, okay, am I going to be able to hire better engineers than that vendor? Then you shouldn't be bottlenecked on the vendor. You want to move quickly, you should be able to branch out from open source, run your own thing, right? So that is, I think, the model that we should build. And unfortunately, what happens in the data lake space today is it's you may remember the famous 𝗪𝗁 format wars of the Hadoop era, right? I mean, where two companies were just like, like they're saying two formats or whatever. They're kind of like doing the same thing to table formats, which defeats the whole point of the thing being open to begin with, right? Yeah. Because most data lake companies are a query engine or like a data science stack, and they're basically going and upselling users, hey, use this format, use that format, including Hudi, right? Like, but the real problem here is they have to go and hire the engineers and do the ops, and like their data engineers have to get every optimization right for that organization to, someone signing the check high up is like, oh yeah, you are like better than the warehouse, or you are now future-proofed, for the organization to see the benefit. So I think if we don't fix this problem this way, it's not about technology. I think we can fix all the gaps, but I think this is the problem that I see. The managed aspect of it, there's no easy way to get started. So otherwise, I think it'll remain in the cloud. Cloud warehouse will be the entry point, and you build a lake when you're suffering from cost or openness, or you want data science team. That's how it will be if you don't fix it this way.
Quick question on that front, and I'm thinking about our listeners who, we certainly have listeners who are sort of managing complex data lake infrastructure, but I'm thinking about our listeners who maybe started with a warehouse and they know that the data lake is inevitable in some ways for their organization. But to your point, that can probably be a big step. What are the things that they need to be thinking about, or even sort of planning for, 6 months or a year away from sort of the inevitability of like needing a larger data lake infrastructure? Are there decisions or architectures or, sort of even ways they think about data now that will help them make that path smoother, even though the tooling isn't quite there to make it easy for them?
Yeah. So I think first thing I would say is like, do more of the streaming event-based or the Kafka hub kind of like architecture, right? Because it really having the ability for you to get all your data streams in a single kind of like, firehouse, and then you can now tee this off to the warehouse or to the lake. You have that flexibility. I would say most people who are in the journey today are using like a opaque kind of like data integration pipe, which takes data from a data like lake, and let's say Fivetran, for example, or Fivetran, or, by the way, really great services. But I'm just like, the architecturally, you just don't see the tap into the data streams. It's so you really have to
like there's
capture
there's like a core data infrastructure pipe that those tools actually need to feed into for you to actually feed it out into your own.
Yeah. Correct. Yeah, switching my hat a little bit, if you look at my like my life at Confluent, like what we are trying to build was, okay, you do like the source connect and the sync connect are kind of decouple. So you get the CDC logs from like an Oracle or any database, and then you can feed it to many other systems. So a lake and a warehouse. So make sure your data can flow into both, and you have the optionality to pick which one you want to send where. That's one. The other thing is start with probably your more the raw data, move that to the lake. That's where you have most of the data volume. And since it's usually in a 𝗦𝗵𝘁 schema, not optimized for like, analytical queries, that's where probably you're spending most of your cost on a warehouse as well, because like they're not really in that schema. So those are like really good candidates for you to start. And then in most scenarios, the derived tables, you can keep them there. They're more performance sensitive. So you can slowly migrate them over here, right? And then what you need in the meantime is you should really push for your cloud data warehouse provider for better external table support, because like they have no incentive to do that unless you force them to do it. Right? Because technically speaking, for organizations, what I can see is, okay, I'm using pipeline company X, and then they're using data warehouse Y. And then if you want to now build a lake, right, and offload your raw, like, you want to build a lake, and going back to our first question, you want a raw data and a derived data layer. You want to move raw data out. I mean, if you do it, then all the SQL has to still run, correct? Like for you to build the derived data. So that is where I think there is stickiness and like lock-in points for warehouses, where unless that SQL can run in a reasonable amount of time on the lake, this project would fail, right? So for example, in Hudi, we just added DBT support so that you can get raw data tables in Hudi. And now you can use DBT to probably like transfer over. We'll be working towards more parity or more standardization. We are today as standard as what 𝗪𝗁 is, right? So you can now use that and use DBT to do the transformation on the lake even. There should be a way for you to move your workloads to the lake seamlessly. Look, think about those abstractions, whether it's DBT or Airflow, or like, how compatible SQL is. Think through all these things. But if your cloud warehouse provider provided better external table support, then you can keep those queries running, even though if you offload the raw data lake, you can query, like try a Presto or some other lake engine in the meantime, as you decide how things are going, right? So it's not going to be an easy switch. This is going to take a year or like at least 6 months for you to switch a reasonable amount of data. So planning ahead around all these touch points is what I would kind of like advise to think through first.
Sure. Well, I think that's really helpful because, the question I asked was what do you need to be thinking about if you're sort of going from a warehouse-based infrastructure and then adding the lake infrastructure? And you would think that, the answer is more around the lake, but it's actually more around the orchestration and the pipelines and giving yourself option value as it relates to all the various components of the stack that are going to arise from moving towards the lake architecture.
Right. I've seen many companies, right? So I categorize them into two buckets. One is if you don't do this right, what happens is there is a lake, but no one's using it. And then over time, the data quality goes like, it slowly, these projects start to fizzle out if you don't do this right. The ones that succeed have top-down kind of energy to say, okay, we're going lake first, and we're going to like revamp the whole thing. In lots of scenarios, for example, the lake comes in when data science comes in. When data science comes in, usually what comes in is data scientists would show up and say, hey, okay, fine, you want me to improve your app, but give me some events. Tell me what's going on in that. Then Kafka comes in. And then you pump a lot of events, right? Yeah. And then that's when the data volume spikes. And then that's when people are like, oh yeah, wait, I need lake, right? This is kind of like how that cycle works typically. People who start like that have a lot more drive to get it done that way. And what we try to, the missing puzzle there is moving data from a warehouse and replicating the database of SaaS data that you may already have in the cloud warehouse. But those are people who are more leaning on I'm going to pay the double cost of warehouse and lake for us sometime. And then over time, I'll figure out, how to move things. And I think this will be the most interesting thing to watch, because right now, given the performance, where things are, right? Lake is super optimized for running large scale data science, machine learning workloads. The warehouses are really optimized for running like BI. Then I think the BI workload stays there, the data science workload stays here. I think we as we build tech, I think maybe they will more BI goes. That's what the rise of Starburst tells you, rise of Presto tells you, right? I think it's very interesting times, I think, to be building data.
It's going to be super fun. It's going to be super fun. Well, Brooks is telling us that we're at time, but I have one more question for you. Sure. And this kind of goes back to where we started with the origin of Hudi. I'm interested to know, so you got it running with 3 engineers into production in a pretty short amount of time, for developing a new technology that's sort of managing the scale. Was there a sort of feature or optimization in the business that sticks out in your mind as an early win? I'd just love for our listeners to hear okay, so you developed this amazing technology. I'm sure we have users of Hudi or people who want to use it, but I just love to know what was an early win inside of Uber that came directly from the technology?
Yeah, there's a direct dollar value attached to that project at that point, dollar value that exceeds hundreds of millions of dollars, because we were able to run fraud checks a lot faster, which meant we report to banks a lot faster. And you can imagine how complex these checks would be. They're very hard to write those in a streaming sort of way and get it right. But if you had a Hive query basically, or something like that, right? We needed near real-time data, not like real-time, but we needed to be running some checks like every hour, for example, as opposed to every 12 hours or every, and you can imagine, right, at Uber's scale, the amount of like rides and everything, like the banks typically give you money back, more money back if you report sooner. That's kind of like how it works. Sure. Again, don't quote me on this. It's how it was there. I don't know how banking rules have changed.
This is not financial advice.
Yeah, this is not financial advice. And that was the main driver. And then, of course, there was like intrinsic. Uber it starts raining, it affects our business, right? There's like a huge concert, the traffic changes. So intrinsically, the business had real-time needs. And there's sometimes hard to put a dollar value around it, except for we can count the number of times people wish data was there sooner. This table was built faster. But the real tangible dollar value was we can do all the background things, rider safety, for example. We can do all these like background thingies, like tasks and data processing that we do to make the Uber experience really better, can run faster, quicker, more incremental. That is sort of thing. And this was actually not a very, I at least came with that mindset because at LinkedIn, the main thing that we would try to incrementalize was people you may know, for example. It's a pretty complex graph algorithm, but the whole, like, we spent a lot of time around, hey, if you and I connected now, and then it'll be cool to, like, I go to LinkedIn and then I get the thing right away. Probably they've made it work now. I haven't kept track, but we were in that mindset. Okay, yeah, let's make all the batch jobs incremental. There is no reason for them to be running full batch and eating up our entire clusters, right?
Sure.
So that's sort of how we went about it.
Amazing. Well, Vinoth, this has been an amazing conversation. I know we could keep going, but we're at the buzzer. Thank you so much for joining us. I learned an immense amount, and I know our audience did too. So thank you for sharing some of your time with us. In this recap, I have two takeaways. One, I love that he called himself a one-trick pony. I think he was very authentic and humble, but that was just hilarious to me. The other one, which we talked about right towards the end of the episode, sometimes you think about the gains from sort of building your own infrastructure. How do you calculate ROI on that? Is it engineering time saved, et cetera? But he was talking about financial transactions to the tune of hundreds of millions of dollars, which is wild. And those sort of stakes are really, really high. And so that was just amazing to me. I wasn't expecting that quantity of, sort of ROI impact, but it's massive. So that's just, man, that's crazy.
Yeah, 100%. I think it was super, super interesting conversation that we had. I think that we managed to make much more clear what the data lake is and why it is important, and what's the distinction also with a lake house, where things are going, where they are today. And we had like a pretty technical conversation, but without getting into like too much technical detail.
Yeah.
But it was very, I don't know, I really enjoyed this conversation, and we definitely need to get him back. I think we have
no question
much more to discuss about. We didn't have the time, for example, to talk about open source projects governance, like what's his experience there, why it is important.
Yeah, I'd love to hear more about running a project like Hudi within the Apache Foundation. I mean, that would be so interesting to hear about.
Yeah, 100%. So yeah, hopefully we will manage. I think he was the first guest that had like an immediate relationship with a data lake technology. There's more out there. Hopefully we will manage to get more on the show to discuss about that. both like lakehouse and data lakes and like everything. So yeah, I'm really looking forward like to have him back on the show again.
We'll do it. All right. Well, thanks again for joining the DataStack show. A lot of great episodes coming up. So make sure to subscribe and we'll catch you on the next one.